Okay, so here comes the next problem. Next problem is as follows. We have a marshmallow. Okay, so here's a marshmallow. And the marshmallow has a volume of 20 pi centimeters cubed. Okay, it's a static volume. This is an immutable volume of this marshmallow. We can't compress it. The volume is always going to be that. Along comes, a press, and this press is going to, here's the press, and it's going to go down, and it's going to squish the marshmallow from above. So the marshmallow is going to get shorter, but because its volume is static, it's going to get wider, right? So after some pressing has gone on, it's going to look more like a hockey puck ratio proportion than it is going to look like the standard marshmallow proportion. This particular marshmallow, when it begins, has a width of, or a diameter, I guess, of 4 centimeters, and it has a height of 5 centimeters. Okay, so the press is going to descend at 1 centimeter per second. So this is coming down at 1 centimeter per second. And so what I would like you to do is I would like you to solve for a couple of things. I would like you to determine at what rate is the diameter of this marshmallow changing, and at what rate is the surface area of this marshmallow changing when the height is equal to 3 centimeters. Okay, so at what rate is the diameter changing, and at what rate is the surface area changing? So go ahead, pause the video, give it a whirl, and then come on back. Okay. Okay, welcome back. So we're going to do the diameter changing first. So I know we're given some givens. So our given is going to be, well, an interesting one to note here is that the volume is static. So in theory, we could say that dV by dt is 0 because it's not changing at all. Or we could just acknowledge that this is a value that I can substitute in directly because it is a static value. What we are given, we know that dH by dt is equal to -1 centimeters per second. We're given that the snapshot, so the snapshot is going to be at a height of 3 centimeters. Okay, and what we want, so let's look at our wants. Our want in this case is dd by dt is what we're after. Now, it's also important to note that diameter is equal to 2 radiuses, and that's probably going to help us out a bit in this case. So we could say, oh, well, that means that radius is equal to diameter over 2. So I know that the volume, again, is pi r squared h. And I know, well, in this case, the volume is 20 pi is equal to pi r squared h. So I can substitute that in. I can also divide both sides by pi to get rid of those, right? So we know that 20 is equal to r squared h. So this is where we have some discretion in our solution. You can go ahead and you can substitute radius in terms of diameter up here. Okay, you could absolutely do that. And then it would be, in terms of diameter, and we would be good to go. Alternatively, we could solve it in terms of r and find what dr by dt was, and then differentiate this and solve for dd by dt. Both of those methods are going to work. I think maybe what I'll do is I'm going to substitute that radius is equal to diameter over 2 right off the bat. So we're going to get that 20 is equal to d over 2 squared, excuse me, times h. Simplify that a little bit. So we're going to get 20 is equal to d squared h over 4, but I'm going to multiply both sides by 4, so I'm going to just make this 80 to simplify my life a little bit. Okay, so there's our expression. Okay, now different ways to approach this. What are we after? We're after dd by dt. So I could differentiate right now and use product rule, and that would absolutely work. But because I want dd by dt, and there's only one simple little variable here, I'm going to simplify this a little bit, I think. I'm going to divide by h on both sides. So we're going to get, it's going to end up being that d squared is equal to 80 h to the negative 1. Okay. And so now I know that I want dd by dt, so I'm going to differentiate. So dd by dt, so it's going to be 2d dd by dt, that's a d there, it's hard to see, is equal to, I guess that's going to be negative 80 over h squared times dh by dt. Okay, lovely. So now I know what dh by dt is. It is negative 1. And I know what h itself is, because we wanted to know, that's our snapshot, it is 3. So I can do some substitutions on this side. So we're going to get negative 80 over 3 squared times negative 1. And over here, dd by dt is what we're after. What I don't actually have is what the diameter at this moment is. But we have an expression for this relationship, right? So we know that this expression right here is true. So 20 pi, where are we at? So we know that 20 pi is equal to pi r squared h. I guess I could do it without even the pi. I could just say that 20 is equal to r squared h. And I know that for the snapshot that r is, or the h is 3, right? So it's going to be 20 is equal to r squared times 3, divide by 3, divide by 3. And we're going to get then that r is equal to the root of 20 over 3. But I need diameter, so diameter is going to be double that. So that means that diameter is going to equal, or make it uppercase, diameter is equal to 2 root 20 over 3. Now, be careful, let's make sure that the root includes all of that. So there is my diameter. And so I can take and I can substitute this value for the diameter into here. So we're going to get times 2, and then it's the root of 20 over 3. So I can then do some simplification. So I'm going to just make some number approximations that are going on here. So on the right-hand side, negative times a negative is a positive, so that's going to just be 80 divided by 9. So I don't know, like, what is it? 8.8 repeated, I think. Yeah, 8.8 repeated. So this is going to be 8.88 repeated. Okay. And over here, this guy is going to be 2 times 2 times the root of 20 thirds. Oh, that's not 20, 20 thirds. And when I do that, I'm going to get that is 10.33-ish. So 10.33-ish is dd by dt. I'm going to divide both sides by 10.33, divide by 10.33, and those guys are going to go away. And we're going to find out then that dd by dt is equal to whatever that expression is. I don't know, like 0.82 or something. So 0.8 repeated. So 8.8 divided by that last answer, second function answer. We're going to get 0.86, so 0.86. So 0.86. So we need our little concluding statement, and so we would say something along the lines of, therefore, the diameter is increasing at 0.86 centimeters per second at that moment. Okay, lovely. So let's do the part B of the problem, and that is looking for the surface area. Oop, that didn't work very well. Surface area. Yeah, my tablet's turned, that's why. Okay, so we got surface area. So I know that surface area is 2 pi r squared plus 2 pi r h. And none of that's static, right? Because the surface area is changing, the radius is changing, the radius is changing, and the height is changing. And what we want to know in this case is we want to know dSA by dt. So I'm going to have to differentiate kind of right now. So I'm going to differentiate. So we're going to have dSA by dt is going to be equal to 4 pi r dr by dt. Plus, this is going to have to be a product rule question. So we're going to have plus 2 pi dr by dt, so derivative of the first times the second, h plus the first, which is 2 pi r, times the derivative of the second, which is just 1 times dh by dt. So there's the expression. We know what dr by dt is. We know, because we just solved, well, we know what dd by dt is. And so if we know what dd by dt is, that means that dr by dt is half of dd by dt. So if dd by dt is 0.86, then we can conclude that dr by dt is 0.43. So we know that dr by dt is equal to 0.43. So we can do some substitutions now. So we know that 4 pi, and we want to know when well, we have the radius. Again, it's not a very nice expression. It's root 20 over 3. So this is going to be root 20 over 3 times dr by dt. Well, dr by dt is 0.43 plus 2 pi dr by dt is 0.43 times the height. Well, the height is 3 plus 2 pi, we know the radius is the root 20 over 3, and times dh by dt, and that was a given on originally of -1. -1. So now all we need to do is dump that into our calculator to find out what the surface area is. So dSA by dt is going to be equal to, grab my calculator here, 4 pi times the root of 20 thirds, times 0.43 plus 2 pi times 0.43 times 3 plus 2 pi times the root of 20 over 3 times -1. And our final answer there, if I've typed it in properly, which I'm hoping that I have, is 0.583, or 5.83, excuse me. So 5.83 centimeters squared per second. So our concluding statement is, therefore, the surface area is increasing at a rate of 5.83 centimeters squared per second. Okay, great. Thank you. I'm going to do a couple more, and I'll put those up in a bit.